Hello all, welcome to the third lecture on DIP lab through Octave. In last lecture we have discussed the histogram and histogram equalization. How do we calculate histogram and how do we perform histogram equalization in Octave. Today we are going to discuss the spatial domain filtering operation performed on image. So I want to start my lecture with the previous experiment, last lecture experiment, in which I have shown you this code, in which I have told that to calculate the histogram of an image, we use the function imHist, and to equalize the histogram, we use the function histeq. So when we run this, we see that the output in the output, this is the original image, this is the original image histogram, and this is the output image, and the output image, its histogram is this one, and it is varying from 0 to 1. Now I told that after histogram equalization, the output gray level will range from 0 to 1 only. If we want to convert it into 0 to 255, then what can be done is, so here after doing this, what we have got dj, and j's gray level is varying from 0 to 1 only. So if we want that j's gray level vary from 0 to 255, so what we will do, we will multiply j by 255. We will multiply j by 255. So what is happening, so you see the range which was previously varying from 0 to 1, now it will vary from 0 to 255, because we multiply, if we multiply 0 with 255 we get 0, and if we multiply 1 with 255 we will get 255. So we will get this range, j range, in 0 to 255. Now this can be done if we want to change the level range from 0 to 255, but once we convert this into this range, we cannot directly use im show. Now why? Because after doing this we will get in some values in j which will be fractional, so we cannot display those fractional values. So for that, what we need to do, we need to convert this its class into unsigned int 8. So before displaying this, what I will do, j equal to u int 8, u int 8, and then j. I will convert its class to unsigned int 8. Now if I run this, then now you can see this is the output image, and its gray level is ranging from 0 to 255. 0 to 255. So this is how we can convert the gray level range from 0 to 1 to 0 to 255. Now I had also told that I had asked you to explore this subplot to label these images. So we use the keyword title to give title to individual images. Like the uh, title I have given to the first image is histogram of input image. Histogram of input image. This is the title to the second image. The first image title is input image. So whenever we are writing subplot and we are displaying something, after that we give title to that particular image, and that appears in the figure window to that particular image. Like this is input image that is appearing here. This is histogram of input image that is appearing here. Then this is output image. This is output image is appearing here, and histogram of output image is appearing here. So this is what we have discussed in the last class. Today, in this class, we are going to discuss the spatial domain filtering. So, how do we perform spatial domain filtering? Let's see this. So, now let's clear the workspace, since two variables are already available in the workspace. So, I will clear them. So, the command for that is clear. Then CLC, it will clear the command. So, what I will do, I will just read one image here, and then I will perform some filtering operation on it. So say the I is the variable in which I read the image. So I am read, and in single quotes or double quotes, the image name. So the image name, let's take low contrast on low contrast, or let's take this cameraman and dot jpg. It's up to you whichever image you want to take, that you can take on whichever file you on whichever image you want to perform operation, that you can take here. So I take this and read it into the variable I. Now I since we are performing the filtering operation, so I have to take the filter coefficients into the new variable. So f1 is the variable in which we will take the filter coefficients. Now how do we define filter coefficients is, first, since in Octave and MATLAB everything will be in the form of matrices, so in this also, this filter also will be in the form of matrix. So this filter we are going to take is 3 cross 3 filter. So all the elements will be 1. So 1 space 1 space 1. So this is first row. So this is first row, and as soon as we put the semicolon, it comes into the next row. So this is first row, all the 3 columns. Then I will give the 3 columns of the second row and 3 columns of the third row. So we write it into the square bracket, 1 1 1, then semicolon, 1 1 1, then semicolon, 1 1 1. So space gives you the distance difference between the columns, and semicolon will take you to the next row. So when I enter this, you see I have got a 3 cross 3 matrix, 3 by 3 matrix, or and all the elements are 1. Now, what do we do in the averaging filter? So here, if we want to see the averaging filter, then we slide the filter, all over the image like this, and we take the average and we put the average value at the center coefficient of the filter, So there we put the average value. So for that, what actually we say that, the convolution operation. So to perform convolution operation, here we have a function called con2. So since it is two-dimensional signal, image is two-dimensional signal. So to perform convolution operation, we have the command con2. So so the output image will have the convolution operation con2 of input image and F1 filter F1 filter. So it will perform the uh, convolution between I and F1. So convolution means what will be done on image I. This filter will be slided like this and like this, and the average of every time the average will be calculated, and the average will be assigned to the pixel which is coinciding with the center of this filter. So this is what we call convolution. So on to we this function we use. So we have got the coefficients in this O variable. Now this variable, this still we have simply performed the convolution only. We did not divide it by 1 by 9. Since we have to divide it by 1 by 9, why? Because the sum of the coefficient is 9 here. So O will be divided by 9. So O divide equal to 9. So what would this do? This will divide the coefficients of the variable O by 9 and assign them into the variable O only. So now you can see here, we can see the coefficients. Now, uh, if if I want that this range should vary from 0 to 255. 0 to 255. So what will I do? I will first convert this O range from 0 to 1. So to convert it into 0 to 1, what will I do? I will find the maximum value of O, and I will divide all the coefficients of O by the maximum value of O. So by doing that, what will I achieve? I will achieve that the coefficient of O will the values of O will range from 0 to 1. So let's do that. So let's find the maximum of O matrix in variable M. So we have the function max and then max and then the input argument O. So what will this first max do? This first max will find the maximum in all the columns. So here you see this is a two-dimensional matrix like this two-dimensional matrix. The first max will find the maximum in all the columns, and here we will get a row of all the maximum of all the column we will get at the as the output of this max function. Then this second max will give us maximum of all these maximums from the column. So we will get overall maximum of that matrix by doing this. So that will come into the variable m. So this we can see. So the maximum value in this O is 251. Now, if we want that this should vary from 0 to 250, 0 to 1 only. So if I divide O by this value m, then what will happen? It will range from 0 to 1. So O divided equal to m. So O will be divided by m and assigned to m only. So now we can see that this ranges from 0 to 1. The O values ranges from 0 to 1. Now if we want that this should range from 0 to 255, so what can be done? O is multiplied by 255. So O star equal to the O will be multiplied, all the coefficients of O will be multiplied by 255. So the range of O will vary from 0 to 255. So this we get in the output image. Now you see, now the class of this O is double, and we have got here the fraction values. So what we need to do, we need to convert this into the unsigned int so that we can display the output image. So for that, what we need to do, O, sorry, O equal to u int 8. We have changed the class of variable O to uint, and we have assigned it into variable O. Now you can see we have got the integer values in the variable O. Now if I display both the images, image I and O in a figure window. So subplot. I want to display only two images. So 1 comma 2 comma 1. At first position I will display I am show the input image I, and then at second position I will display the image which is stored in. So now if I see the figure window, so so this is the original image and this is the filtered image. This is the filtered image. So here we are not able to see much difference. Why? Because uh, here we know that the averaging filters perform the blurring operation. So in blurring operation, and we also know that the objects of the dimension of the filter size will be blurred. So here we hardly find any object which is of the dimension of 3 cross 3. So 3 cross 3 is going to be very less. Now here we can see that a black border is appearing at the boundary of this image. Now it is because you see here we did not use the uh, valid keyword along with the convolution. So in convolution, if we do not use the valid keyword, then what happens? It will extend the boundary of output image by 2 in both the directions. By 2 in the both the directions. So that is why we have started getting this boundary at black boundary at the output. Now This is how we perform the spatial filtering operation in the image. Now, if you remember this from the theory, that this is one example of smoothing filter. So what is done? This is the image which is taken. So on this 15 cross 15 averaging filter was applied, and then after thresholding, we got this image. So what was the aim to perform this of these operations was, we are interested in large and bright objects of this image. Large and bright objects of this image we are interested in. So what we do first, we perform the 15 cross 15 averaging filter on it. We perform 15 cross 15 averaging filter on it. So by doing this, what we are able to do, we are able to blur the objects which are smaller than 15 cross 15 dimension. So very small objects will be blurred, and then the remaining coefficients will be thresholded. Thresholded means the intensity level above a certain value will be assigned 1, and below that value will be assigned 0. So this what we have got as the output, that is a binary image. So binary image means this is 1 and this is represented by 0. So for this, if we want to look at the code, so I have written a code for the same. So the CLC, clear all and close all. Hope you know about these commands now. Now I read an image into the variable I. So I have taken the same image and I have read into the variable I. Now since I want that my filter is of 15 cross 15 size. So in this case it was 3 cross 3. So I have uh, taken the matrix and I have assigned the values in manually. So I have entered the values manually and I have got this 3 cross 3 matrix. But now if I have to enter a 15 cross 15 matrix, then it will consume much time. Then for this we have a function called once. So what will this function do? This will return us a matrix of the dimension which we pass as the input argument of this function. So if we want a 15 cross 15 matrix of all the elements 1, then once 15 comma 15. So this function will give us the matrix of all the elements 1, and that will be assigned to F1. So in F1 we will get a matrix that is of same dimension on 15 cross 15 dimension. Now I perform convolution operation between I and F1, and I pass the third argument as valid. So in this valid, it will not, the filter coefficients will not go beyond the boundary lines, boundary edges. So here the obviously the output image will have dimensions less than this input image, but we will not get the uh, artifacts at the boundary of the image, output image. So this keyword I am using here. So it will perform convolution between input image and the F1 filter. Now after that, what do I do? Since this is simply the filtering, that means convolution operation. So in averaging filter, what do? We divide it by the sum of all the coefficients of the filter. So sum of all the coefficients of the filter will be in each row we have how many coefficients? 15. So 15 cross 15, how many coefficients total? 2, 2 to 5. Total 2 to 5 coefficients. So the sum of all the coefficients will be equal to 2 to 5. So what I have done, I have divided O by 250, 225, and I have assigned the value into the variable O only. This means what? All the elements of O will be divided by 225, and the same matrix will be assigned to O. Then what am I doing? Now if I want that my range, the values of O should range from 0 to 255. So what I will do, first I will divide O by maximum of O, maximum element of O. So how do we find maximum of a matrix? Max of O. So this will give us maximum of O, and if I divide it O by this, that means all the coefficients of O will be divided by the maximum value which is available in O, and then all the coefficients of O will be multiplied by 255, and those coefficients, that matrix will be assigned back to O, right? So by doing this, what we have achieved? We have achieved that the O ranges from 0 to 255. Now we are performing what? Thresholding operation. So how can we perform thresholding operation? It is quite easy. In one line code, we can perform thresholding. So see what I have done in thresholding. I have done two types of thresholding. So in first type of thresholding, I have taken the output in P, and in second I have taken R. So in P, what I have done, whatever values of O are greater than 60, whatever values of O having greater than 60, corresponding to them we will get 1 in P, and remaining all will be 0 in the variable P. Remaining all will be 0 in the P. So P will be the matrix of the same dimension of the O, and P will be 1 wherever the O is greater than 60, and it will be 0 wherever O is less than 60, less than or equal to 60. So we will get a uh, binary values in P. So we will get a binary matrix that will contain 0 and 1, and it will contain 1 if O is greater than 60, and it will contain 0 if O is less than or equal to 60. So another we have taken R. So in that thresholding we have performed using the intensity value 120. That means whenever the value of O is greater than 120, the value in R will be assigned 1, and otherwise it will be assigned 0. So that means R will also be same dimension of O, and the the R will contain 1 if O is having intensity which is greater than 120, right? So this thresholding is clear, I hope. Then I display all these four images. So in I divide the plot window, the figure window into four boxes. So two rows, two columns, and at first position I display the original image. At second position I display the filtered image. So after this, here we have got the filtered image. This is the filtered image. So I have performed convolution using this 15 cross 15 filter, and then I have made it to have range from 0 to 255, and this is our filtered image. Now at third position I display the thresholding using uh, the threshold 60, and at fourth position I display the thresholded image using the threshold 120, using the threshold 120. So let's run this. What happens? Okay, so this is our original image. This is the original image, and on this we performed 15 cross 15 filtering. So you see the smaller objects than the 15 cross 15 have disappeared from the filtered image. They have disappeared from the filtered image. So smoothing filter are generally used to blur the objects from the image. So we have blurred the objects which are smaller than the 15 cross 15 dimension. Now after that I have thresholded it using the threshold 60. So there will be more number of pixels which have the intensity value greater than 60. So you see here we have got so many number of pixels which have the intensity value greater than 60. So these all pixels which are appearing in white, they are having the intensity value greater than 60 in the filtered image. Now since obviously if I change the threshold from 60 to 120, the number of pixels which have the intensity level greater than 120 will reduce. So here these are the pixels these are the pixels which have the intensity levels greater than 120. So here we get the pixels uh, which have the gray levels greater than 120. So what we have achieved here, our target was to identify and separate out the larger and brighter objects from this image. So you see, so this is a larger object which is available here. These all are larger objects which are available here. Then this is a brighter object. This is also available here. This is also a brighter object which is available here. This is also a brighter or larger object. So all these are available here. Now if we consider this, then here this is little less brighter than the remaining these values. So this these uh, objects are quite clearly visible in this thresholded image. So this is how we can perform the filtering operation. So hope this lecture is going to be useful for you. That's it for this lecture. We'll meet in the next lecture. Thank you.